Good morning, professors and friends. I'm Amalina and my roommate is Vanessa. Today we're presenting to you... Alright, just kidding, let's get right into it. So the past 13 weeks have been interesting. We've made sacrifices, experienced mental breakdowns, but more importantly, we had a fun time. So here's that journey. But before we begin, big thanks to Telegram because GitHub never heard of her. Alright, so the very first thing a robot can do is move. Because like us, the robot has to be able to run away from responsibilities. Next up, the LEDs. The green LED array at the front lights up when stopped and runs like a Razer keyboard when it is moving. The red LED array at the back flashes at a rate of 250 milliseconds when stopped and flashes at 500 when moving. Not forgetting audio functions to play some sick beats. Upon connection, it plays a Nokia ringtone. Next, we play the Me channel music while the robot is running. And lastly, to mark our sad victory, we play Take On Me. Next, we have an Android app to control our robot. It is created with the MIT App Inventor and the guidance of my favorite YouTuber, Doc R. Our robot also has Bluetooth capabilities to receive commands from the app. Now, how do we put all of this together? What you're looking at is our robot's Maxi architecture. Looks complicated? No worries, it is only a facade to seem like we do things. In the Android application, there are three components: the user interface, logic, and Bluetooth. The UI is what you see here. When a button is pressed, a magical force commands the robot to move. Just kidding. The backend logic is written such that each button in the app has a unique data packet. When you press a button, the app sends this data packet to the HC06 Bluetooth module. This module is physically connected to the Freedom Board's UART receive line. So, whenever the board receives a data packet, the UART IRQ handler puts it in a message queue. T-Brain then gets the data packet from this message queue and passes it to reveal the command. If it is a movement command, T-Brain passes the command to determine which direction it is and sets a thread flag accordingly. The corresponding T-Moto thread then calls the correct movement function. Next is the audio control thread. Basically, T-Audio checks the audio state and plays the corresponding music. Lastly, the LED control thread acquires a semaphore at periodic intervals, checks the RLED frequency state, and controls the LEDs accordingly. Right, quiz time. Who's that Pokemon? It's our robot. And this is us being drunk drivers. Enjoy.
Go.